On this episode of This Week in Space, we're talking about the nova star you'll be able to see from home with astrophysicist Carlos Badenes, professor of physics and astronomy at the University of Pittsburgh. Stay with us.
Podcasts you love
from people you trust.
This is Twit.
This is This Week in Space, episode number 121, recorded on July 26, 2024. An exploding star near you. Hello and welcome to another episode of This Week in Space, the A Visible Nova in the Sky Near You edition. I'm Rod Pyle, editor-in-chief Badenes magazine, and I'm here as always to my great chagrin with my pal Tarek Malik, editor-in-chief at space.com, the one and only space.com. How are you today, sir?
Well, I was better until that burn, you know?
It was the burn. That's how I expressed my great affection for you. So a little bit, we're going to be joined by our guest this week, which is a professor of physics and astronomy, Dr. Carlos Badenes at the University of Pittsburgh, to talk about novas and supernovas and other associated things, but most importantly, an upcoming nova, which you're going to be able to see what will look to the naked eye like a brand new star. And it's called
Corona Borealis. Also
well done. You win the lollipop. But before we get there, please don't forget to do us a solid and make sure that you like, subscribe, and do all those other groovy podcast things on the podcatcher of your choice, whatever you use, because guys, we need the numbers, we need more thumbs. But before we have those, let's do a space joke. I wrote it this week.
Oh, wow. Okay.
Yeah.
Stand up. Rod's stand-up debut. Right?
No, you'll be sorry. Hey, Tarek.
Yes, Rod.
Why did the star skip 2 years of calculus?
I don't know why.
Because she was incredibly bright.
I see it.
Wow, she's got. Oh, we got a double dip on laughter. Okay,
nice.
or a double needle drop. Now I've heard that some folks actually swear off dead humor when it's joke time on this show. Mm-hmm. But you can save the cosmos from our humor by sending us your best, worst, or most indifferent space joke at twit@twit.tv. And we get a few, but we can always use more. So please send them along. All right. Boy, do we have a bunch of headlines today.
Yeah, well, we can only do the top three. We don't have to do a lot. I picked three good ones.
Well, but there's a lot of good stuff. So my favorite of the batch, if I may.
Yes.
Hey, this is Rod dropping in for about 10 minutes in the future. We said Curiosity in this story, but what we really meant to say was the Perseverance rover. Forgive us. Was the discovery by the Curiosity rover.
Dun, dun, dun.
Yeah, well, this is a dun, 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 because it has come across a rock and they're being careful. We're not having another ALH 4001. What was the
180?
Yeah, we're not having another. Hey,
45.
there's life in that there meteor with Bill Clinton episode, but it has found a rock that looks like it might have fossils in it.
Yeah, this is really well, or that it has the signs of that. Yeah, that's. Do you want to go into this one? It's your pals at JPL.
No, go ahead.
Yeah,
go ahead. But it's both physical properties or visible resemblance and physical properties, right?
Oh yeah, it's got all the things. I mean, NASA went all out on this. They made like a video, and then they made like a TikTok, and then they made here's all the pictures of it. They even have a little animation of Curiosity looking down at the rock, like in disbelief as it looks back at its selfie camera. But for people who don't know, they have a really interesting instrument on the Curiosity rover called Sherlock. Wink, wink, nudge, nudge, and it's designed to look at microscopic views of stuff that rocks that the rover gets up close to or digs into or whatnot. And it was looking at this vein filled rock called I'm sure I'm going to get this wrong. Chayava Falls is what they nickname it. It's like an arrowhead shaped rock, and they found not one, not two, but three intriguing signs that we're going to talk about in a minute that give them hope that they might have found like another like great target for to hunt for life. The first is what we've seen from the older Mars rovers, these nodules, these nodules of olivine, which is a mineral on Earth that is formed in the presence of water. You might recall that Opportunity found little blueberries made of that stuff all around its landing site, and they found that in this rock slate. They also found a really strange red stripe across like the center of the rock. And the red stripe was, I'm going to get it wrong because there's this other stuff that's in it too. Yeah, it's the hematite. The hematite was what the blueberries were made out of. Yeah, that's right. And the hematite is also, one of the water formed molecules. Well, right. That's great too. But then there's these white veins around the red stripe, which they say are these white calcium sulfate veins. So you've got this calcium sulfate stuff, you've got this hematite stuff, you have the olivine, and NASA has said that when they see that stuff on Earth, right, it's with fossil record studies of little microscopic fossils and whatnot, and oh my gosh, did they find signs of life on Mars? We don't know. They're saying that Curiosity has done all that it can because it's a robot. It's not a scientist, and we really need to get samples back. And there was a really cool. I put this one on on the rundown, John. It's line 22. There's a really important thing I wanted to stress. This is not proof of life on Mars. In fact, the New York Times, among others, said very clearly in their headline, NASA did not say it found life on Mars, but it's very excited about this rock. And so. But you can tell that the folks at JPL are really excited in their announcement. They included all these videos and they're super excited about like why they think this is great. And, it's another reason why we got to get those samples back on Earth, Rod. But it may not be critters, but it could be something. It's got these spots that they're really excited in that red stripe, these leopard spots. And that's why they're comparing it to fossil records on Earth and saying, I don't know. Maybe we got it,
Getting samples back is important, but we'd all much rather get a geologist up there.
That's right.
The chance of getting those things in a sample are not great.
Well, but I mean, go ahead.
Well, I just got to say, I was talking to somebody about JPL layoffs last night. Actually, it's our friend Pascal Lee, some of his grad students he's advising because they're down here for a Mars conference at Caltech. And, when you see what JPL's gone through in terms of staff cuts in the last couple of quarters, finding a likely indicator of possible fossilized life on Mars, I think I put enough conditions on that, would be really good for them because they could use they're getting their budget back and indeed an increase. And I mean, this, what a big moment. If this happens, these aren't 8-legged thoats or anything, but if this does turn out to be the real deal, it has major implications for philosophy, theology, science, of course, and a lot of other things. And we'll kind of, a lot of us will be really excited. Some people will be kind of shook up, I think.
Yeah. I tell you, it's like what's next? We're really excited at space.com following the story for try to get some interviews with the scientists. Also ask that question. If it's true, what does it mean? And also explain why they're being so cautious. When they had, and that was 1992, when they announced the possible life on Mars, right, with the ALH meteorite, that was like a televised press conference, and like a rah.
That was an embarrassing moment, wasn't it?
And then they had to back off on that. And they say in this announcement too that there's some mineralogical types of reasons why they could see this stuff, and they would need to figure out what it all means. But this could be like a really big deal, and trying to grab this stuff and bring it back would be really excited. Also, I don't remember the thoats being 8-legged. I thought everything had 6 legs.
Maybe they were 6-legged. I knew it was a bunch. Thank you for that correction.
I'm sorry. I got to call them like I see them on Mars.
Dr. A. Retentive. So let's move on to, I our Starliner update. Now, I wrote.
Oh,
in the
you
box,
gotta say what you gotta say what you called it.
I wrote on the rundown because I wasn't thinking clearly. It was very late at night, and I did write Starliner, but other people are calling it Starliner, not us. But now, and I followed this online, on a number of Facebook pages and other forums, and there are a lot of Boeing defenders out there saying, "Look, all new spacecraft have teething problems, and this isn't unusual. And hey, SpaceX had that chance to do all that development with the Cargo Dragon before they started sending crew up." And there's some truth to that. However, SpaceX was started in 2002.
Yeah.
Boeing's been in the space trade since the 50s. So it's not like they haven't had a chance to learn how to tie their shoes. What's going on now, Dr. Malik?
There was a press conference this week.
Yes,
and we got excited because, first of all, it was a teleconference. And then late in the afternoon, NASA sent out an updated note to say, no, it's not a teleconference. It's going to be a televised press conference. And when they televise things like we were just talking about, that means it's important. And so, and they're going to announce something like definitive. So I had hoped that meant a landing date for Starliner and the crew flight test with Butch Wilmore and Sonny Williams on the space station. They are 50 plus days now into their 8-day mission. And
we'll keep on hoping, buddy.
Yeah, unfortunately, my colleague Elizabeth Howell had this great story about like what's going on. The big announcement is that they're still waiting to finish all of their tests on thrusters and whatnot. They did say that the 45-day battery limit that they were facing with this Starliner, which is how long the batteries are rated for, that it can actually stay up there for 90 days. So I guess that's doing fine. Which, by the way, if they stay up there the full 90 days, would have them coming back like the first week of September or something like that.
Excuse me for interrupting, but I have a question.
Yes.
We hear these initial statements and guidelines, and then they get changed.
Yes.
And I presume they are changed because primarily the engineers and Boeing are saying, well, we said this number before, but that's actually a minimum. There's more than that. Or are we just changing the verbiage to make it feel better?
That's exactly what I think it was Steve Stitch in the press conference said. He said, hey, I guess we kind of made a mistake when we said it was an 8-day mission, because really we meant that
at least 8 days.
At least an 8-day mission. Yeah. And it could go for longer. And remember, Demo 2, that first crewed flight with Dragon, I almost called Starship. Yeah. That was a 2-month mission, and they said, oh, we'll extend it if it looks fine. We could extend the mission, and then they made a very definitive call. There are questions about why it's so nebulous. Why can't they just say, we'll come back home at this point in time? In fact, in the Atlantic, and it's behind a paywall, I'm sorry that we can't show it, but Marina Koren, the space reporter over at the Atlantic, has a very good piece there about how NASA needs to give the spin about this mission, because if just for you and for me, I think it looks like, hey, this mission went up, the spacecraft is working, maybe not as smoothly as we wanted it to work, so we have to make sure it's okay, but it's working at an acceptable rate for now, and we'll bring them back when we're really sure that it's safe to do so. And that's nice and clear, right? Okay, that it went up there, it's a bit spotty. We want to make sure that it's okay. They'll come down. In the meantime, they are safe. They are not stranded. It would have been nice if they just said that, But we can bring them back if there's an emergency. That means that they could come back anytime they wanted, if they had to. So they're not really stuck in space. You see a lot of those headlines, and I think it's very frustrating.
It's got to be, and it's not like it's lost hull integrity or power, or that the life support's gone out or something. And these problems are small and kind of incremental. And the spacecraft works.
But at the same time, they said they were going to come down after like a whatever. I think next time, put a target landing date out before you launch into space, so that people can measure that, right? But then,
or put a target landing month out.
Yeah.
Or maybe in this case, a quarter. Okay, I just had to get one last dig in.
No, but to your point, they didn't say a landing month or a landing date this week. They just said that they've ironed out some processes that they are going to do and they are not going to do after undocking. They will not do manual thruster firings because they want to preserve the lifetime of the thrusters after undocking. They've got more tests out in White Sands to finish because there's some deformation stuff with the thrusters they want to look at. So they've got stuff to figure out. Meanwhile, Sonny Williams, Butch Wilmore, just enjoying their time in space, able to get a lot of extra work done for the ISS crew. So they've got no dearth of activities to do. They're not just twiddling their thumbs up there. And we'll have to see how that goes for them.
Okay, we're running a little long here. So
sorry.
I want to get to Carlos. But you're not going to be here next week, so I really want to give you a chance to get your Diamonds of Mercury story out. So give us a quick capsule, if you would.
Yeah, this is a real fast one. Basically, cool, we had it at space.com, but you might have seen it some other places. But scientists
no other places, my friend.
Thank you. Oh, bless your heart, Rod.
Small and hard. Like a diamond, small and hard.
Yeah, bright like a diamond, right? But no, they scientists used data from NASA's Messenger mission that kind of hit and studied. It studied Mercury from 2009 to I think 2015 is when it finally crashed into that planet, and they have basically been able to discern that there's like a 10-mile thick diamond kind of encrusted mantle that's just under the crust of Mercury because of some readings that they got while trying to understand the core of the planet, and they actually recreated the conditions that they think are there in a lab to create these diamonds. And it's just a really weird type of thing that the planet has, because it's this tiny planet with this carbon-rich magma ocean, and then it would create these weird graphite patches that float up to the surface, and that's what gives it Mercury its mottled, dark, kind of shaded surface. But then just under it is this layer of like super dense carbon, which when they put it at pressures that are equivalent to what they think are in the core of those layers, those magma layers of Mercury, that it created all these diamonds. So it's like, well, if you need a cosmic diamond mine, now you know how deep you have to dig on Mercury to get it,
Finally, a reason to go to Mercury, the other trailer park of the solar system after Venus. I have a quick correction. We got a note from listener Rob after our Starship discussion the other week, pointing out that there are actually catch points on the Super Heavy that are not the grid fins. And he sent a picture of those. So there's a little lug that protrudes below the grid fin, which are catch points for the chopsticks.
Wow.
At least that's what he says. And there we go. So Rob, thanks for catching that. We appreciate it. And hey, never be shy, folks, about telling us what we messed up.
Oh yeah, call us out. Rod in particular.
Won't be like, yeah, especially me. And Tarek, you've got something here.
Yeah, I just wanted to give a shout out to a specific listener, and I don't know their name actually. I only know their YouTube channel name, which is MLQS Glitch. That is MLQS Glitch, because they sent me a very nice comment on my other channel on Space Round Plays on YouTube, where I play video games, etc. And they said, hey there, sir, super huge fan of This Week in Space, and it took them an embarrassingly too long time to find my channel, the gaming one, but they're glad they did. And then they said that you and Rod are the best and make their commute bearable. Isn't that great? We're doing a public service to help people, especially if your commute is like
a fan.
I know.
That's exciting.
And especially if your commute is like what we have in New Jersey Transit, man.
Oh gosh.
I mean, I know any bit helps. So thank you for listening, MLQS Glitch. So
And my last little bit here before we go to our guest is I had the pleasure last weekend of being invited down to San Diego for the Apollo 11 55th anniversary gala at the San Diego Air and Space Museum, which is a lovely museum. It's smaller than National Air and Space or something of that nature. But what's very cool about the San Diego Air and Space Museum is that they've taken, and it's airplanes and spacecraft. So it's everything from the beginning of aviation to, last week. But they've put it in a chronological way. So you have this kind of winding path that wanders through the first airplanes and a Radio Shack from World War One with
I thought you meant like
bad
an actual
biplane out there,
store.
not the store, no. And then you wander through a bit of World War II, and then you get into the space age. And they've got the Apollo 9 command module there and so forth. So it's very, very cool.
Like an
So they had
IKEA about space.
this gala $750 per ticket event, and Buzz Aldrin was there, and Jerry Griffin was there,
Nice.
a flight director from the Apollo era, among many other accomplishments. And Charlie Duke, moonwalker from Apollo 16, was supposed to be there, but because of the CrowdStrike malfunction,
Oh no, he got stuck.
he got stuck in Atlanta for 2 or 3 days. So he had to
Oh
zoom
my
in.
gosh.
And my
Wow.
God, he looked like he hadn't slept for 30 hours and he zoomed in, which he possibly hadn't. But at least he was able to join us by Zoom. But a really neat event. And it was so great to see Buzz. He's still hanging in there. 94 and a half, that
Yeah.
man.
Yeah.
And he gave a nice little speech. And then Jerry Griffin and the museum director had a fireside chat session. And all in all, it was a good couple of short films and so forth. So it was a fun way to acknowledge the 55th anniversary of Apollo 11. But of course, everybody likes round numbers. So the favorite anniversaries are 10, 50, and 100. The next one that space.com would jump all over with lots of what's the word I'm looking for?
No, very informative
headlines.
Informative news features.
Deeply informative news
deeply,
features
yes, engrossing,
with
detailed,
intelligent,
educational
constrained headlines. Will be 60. So I think
we'll be on the moon by then, right? Right, Rod? We'll be on the moon. Yeah? And in 5 years, it'll be 2029.
Yeah.
So that
bet.
means that we'll be on Artemis 8 by then, right?
Now, would you say we?
I mean, like
Talking about the United States?
United, yeah, America.
Oh,
Rah! Where's my eagle? I need an eagle.
Yeah.
But no, we should be on
Anyway,
Artemis
it's-
6 by then, I think.
well, more importantly, we should be on episode like 380 or 510 or something. Oh, well, 520, right?
Maybe we'll be recording in space by then
520. So
on a private space station.
fat chance of that, but I do think we should schedule a special thing for that. Anyway, enough about that. Let's go to a quick break, and we will be back with Professor Carlos Badenes. Stay with us. This episode of This Week in Space is brought to you by BetterHelp. What do you do when you get caught up wishing your life looked like someone else's? Comparison is the thief of joy, and it's easy to envy other people's lives. It might look like they have it all together on their Instagram account, but in reality, they probably don't. Most of us don't. Now, therapy can help you focus on what you want instead of what others have, so you can start living your best life. Now, look, even an astronaut can benefit from psychotherapy. I know I have in the past, and there's no better way to get it than by using BetterHelp. If you're thinking about starting therapy, give BetterHelp a try. It's entirely online, designed to be convenient, flexible, and suited to your schedule. Doesn't get much better than that. Just fill out a brief questionnaire to get matched with a licensed therapist and switch therapists at any time for no additional charge. Stop comparing and start focusing with BetterHelp. Visit betterhelp.com/twist today to get 10% off your first month. That's BetterHelp, HELP.com/TWIS. And we're here with Dr. Carlos Badenes, who's professor of astronomy in the Kenneth B. Dietrich School of Arts and Sciences at the University of Pittsburgh. I'll get this right yet. Thank you for joining us today. How are you?
Thanks for having me. I'm doing great.
Well, we're very pleased to have you here. And of course, as I mentioned, I just had to invite you because I saw this great article about an upcoming visible nova, which is not something we get to see very often.
Nova!
That is true. That is true. It's quite rare, actually.
Tarek, you sound like you just stepped out of Planet of the Apes. Thanks for that.
I was just saying, yeah, I'm excited. It's explosive stuff we're talking about. So
oh, good grief.
It is fun to blow things up. Yeah.
Well, that's true. And if you have the power to blow up stars, that's really quite special. So I guess before we go on with this, we probably ought to tell everybody what a nova is and why it's different than a supernova.
Okay. So I guess one way to answer that question would be to just go for the definition. So a nova is a type of binary system. So you have two stars, and one of the two stars is actually a white dwarf. So it's a dead core of a star that has exhausted its nuclear fuel. And white dwarfs are very dense and very small. And sometimes when this binary system exchanges mass, so the star that's not a white dwarf is dumping mass on the white dwarf, this mass accumulates. This is mostly hydrogen, and under certain conditions this can ignite and get a lot of light, and this is what we call a nova explosion. The reason it's different from a supernova is that has to do more with the history of how these things were discovered. Historically, the first use of the word nova actually just means new in Latin. And that's a term that was coined by this astronomer in the 1500s called Tycho Brahe.
Oh, I was going to ask you about him.
Yes. So Mr. Brahe found a new star. He went out one day at night and he recognized that there was a star in the sky that was not there the night before. He wrote about this extensively. He wrote a book called De Stella Nova, which means about the new star. And from the point of view of the phenomenology, it's very similar, right? It's something that is dim and then becomes very bright. It was not until the 20th century and we started getting better at measuring the distances to things, which allows you to work out how intrinsically bright they really are, that we saw there were two different classes of these new stars. There were the regular novae, which we call novae today, and they're the ones that are very, very bright, which we call supernovae. From the point of view of the physics, the difference is that in a nova explosion, the star typically survives. So the white dwarf, nothing serious happens to the white dwarf. It's still there, and it has a chance to accumulate more material and then explode again, perhaps. Supernovae are different in that they blow the star to smithereens, and that it can happen only once.
And forgive me if I misunderstood it, but for these like white dwarf binary systems, are they both white dwarfs, or is it like? So I'm not sure if I missed that earlier. So
no. In your run-of-the-mill novae or novae, like TCrB, the one that may get bright enough to see with the naked eye in the next weeks or months. The other star, the star that is contributing the mass, what we call the mass donor in the jargon, is a normal star. Okay,
so and that can be like any type of star. It could from run of the mill, or
they're usually red giants, which means they have an extended convective envelope, but they can be main sequence stars too. So anything that can contribute hydrogen and put it like on the surface of the white dwarf.
So just to be clear for our listeners, as you just described, there's the supernova stars, right? The star explosions where it destroys a star. Hopefully it doesn't happen to our sun. I don't think it's gonna, right?
It's physically impossible for our sun to explode as a supernova. So we're
great.
Very safe.
That's great. And the way that I was trying to describe to my daughter, like what this nova like concept is it's like these two friends, that are at a buffet, and one just keeps feeding the other one until it like bursts and says, "Hey, have some more," and then keeps feeding it again until it bursts. I mean, is that about accurate to say?
Yeah, that's about it. There's actually a very interesting physical reason why these explosions happen, and that's the white dwarfs are what we call degenerate objects. They are supported against gravitational collapse by something called degenerate electron pressure. It is a quantum mechanical effect. And they behave in strange ways. So typically, for instance, when you dump a lot of material onto a white dwarf, you try to make the white dwarf more massive, it actually shrinks, which is not the way matter is supposed to behave, right? And one of the features of this degenerate material is that it doesn't generate pressure when you heat it up. in normal matter, what we call an ideal gas, when you heat up a gas, it makes more pressure. This is, anyone who's done a little bit of cooking understands that, right? But white dwarfs don't work like that. And then because of this kind of quirk of white dwarf material, you can have what we call a thermonuclear runaway, which is kind of a self-sustaining nuclear reaction. Mm-hmm. Thermonuclear runaways are very bad news if you're nearby. It generates a lot of energy very, very fast. And this is what makes novae bright, okay? And also some types of supernovae, the thermonuclear ones.
The analogy that occurs to me for the particular nova we're talking about, which is...
we should mention what we're talking about.
Yeah, you took my name away when you
it's
wrote the
right.
question.
It's right there. It's right here.
Where?
It's right underneath where you are.
It's called
Corona.
Corona Borealis.
Thank you. I just see TCrB.
Yeah.
So a rough analogy in my simple-minded terms, which is probably why I didn't finish my astronomy degree, is if I went on a 160-year cruise on a cruise ship and just spent my entire time in the cafeteria eating, and then every 80 years. Every 80 years, I have this momentary shudder where I shed a bunch of mass and an explosion of light and then could sit down and start eating again. I would be sort of like this nova star. So let's talk about this one in particular. So it has a repeatable cycle, which I gather from what you've written is very predictable. I mean, literally down to within weeks. Yes.
So as far as we understand, most novae work in this way. Okay, you have the white dwarf, it accumulates material from the other star, a critical condition is met, and then it blows up. Now, there's a subclass of novae, which we call recurrent novae. And the only reason we call them recurrent novae is because they repeat on timescales that are shorter than the typical human lifespan. In reality, all novae may be recurrent. But, if the recurrence time is something like 6,000 years, we just wouldn't know. But this one we know. This one went off in 1946. So it's kind of due for a blow up. And the people who study it, and here, shout out to the people in the amateur astronomers associations that monitor variable stars, because they do great work. So the people who collect data on the nova are saying that it's starting to do the things that typically happen just before the explosion. There's usually a slight brightening and then a dip, and then it blows up. And it just had the dip, and I think in April. So it should blow up between now and September. We don't know exactly when. We can't predict it accurately, but it should happen soon.
And what's the reddening prior to the explosion from?
Reddening?
Yeah. Oh, I thought you said it got a little redder before.
No, it gets a little brighter, and then it has some dimming. I may have said reddening, but it gets a little bright and then a little dim, and then it blows up, and that's where everyone's like waiting now for it to happen. And this one is special because it happens to be one of the closest recurrent novae to us. So what that means is that it's going to get pretty bright. It's actually going to get naked eye bright.
Oh.
So around magnitude 2. And if you know how to find Corona Borealis, it's a circumpolar constellation, so you can see it at night from a reasonably dark place in the northern hemisphere most nights. What's going to happen is that you will see literally what the namesake of the phenomenon is. You'll see a new star in Corona Borealis, about as bright as the other stars in Corona Borealis. So, and it will get bright and stay bright for maybe a few weeks and then fade away.
So, Tarek, I've decided, since I'm not patient enough to wait for Artemis 3 to land to get that Star Trek chair, you and I are going to spend all our nights outside looking hoping to catch it the minute it happens.
We can place bets. We should place bets with the listeners, everybody out there. Let's all make a plot.
Yeah, but I'm the only one.
It's a kind of thing where it's fun to bet on.
All right. Well, let's go to a quick break, and we'll be right back. So go nowhere. So, Carlos, you kind of touched on this, but for people who are interested in astronomy and perhaps have a nice pair of binoculars or a telescope, maybe you could tell us what we're going to see. I mean, even with binoculars or a telescope, you're going to see a star.
Exactly. But, and this is something that maybe in this modern era is lost a little bit. Like the reason Mr. Bry immediately recognized that there was a new star is because he knew the night sky very well. And most of us, even professional astronomers, don't really know the night sky very well that much because, we live our lives now flooded in artificial light, and we live in inner cities where it's very hard to see any stars at all, even if the skies are clear. So the exciting thing is that you're going to see a new star, but it will look like any other star. It wouldn't look any different than the other stars in Corona Borealis. So that's basically it. You're going to see a star that wasn't there before. And if you're in a place where you get enough clear nights, you may actually see it noticeably getting brighter and brighter and then dimmer and dimmer every night. You've had the patience for that sort of thing.
I remember as a young man, sorry, Tarek, just one follow-up. As a young man, the moment I realized the direction astronomy was going in modern life, my family had taken me to Disneyland. And I thought, for some reason, I think we had just been on the flight to Mars ride or something. I thought, I want to look up at the sky. I looked up at the sky and it was orange. And you could see the moon and maybe one or two bright stars. And
that's pretty much it. Yeah.
That was pretty much it. In the 60s, as a kid, I used to do a lot of stargazing from my backyard in Pasadena, California. And you could actually see a fair number of constellations. And I saw the Leonids back in 1966 when they had that big burst in that shower and saw a lot. And that's not the case anymore. So your point about light pollution is well taken.
This is a trigger issue for many astronomers. One picture or set of pictures that I've seen that it kind of stayed with me. There's the Mount Wilson Observatory, which is just outside of Los Angeles. And if you're from California, you've probably been there, right?
Right.
And this is the observatory from which, Edwin Hubble discovered the expanding universe. It has a lot of history related to it. And you take a picture of LA from Mount Wilson in the 1910s, 1920s, and you take it now, and it's just completely different. You cannot do any astronomy from Mount Wilson today because LA just completely floods everything. And that's something that has happened, in the recent past, in the last 100 years.
I can actually top that. I used to work at Griffith Observatory, which of course, nothing like Mount Wilson, but we had
it's even closer.
A 12-inch Zeiss refractor from pre-World War II, beautiful instrument. And you're right. I mean, we could see the moon, couple of planets, and then if you look at anything that's dimmer than that, it's surrounded by this glowing field of sky background, which is very frustrating when you have this great instrument. But you're right.
Well,
I mean, it's perched. It's almost in the middle of Los Angeles, the way it's perched.
The part of this that really riles me up is that that light we're sending out of the sky serves no purpose. It doesn't make anything easier on the ground, actually. And we use artificial light in a way that's very inefficient. There are a lot of street lights that are actually pointed up or send a lot of their light up. And until we develop levitation, that's not really very useful because people are usually on the ground. So that and it's a waste of energy, and it just makes everyone's night sky experience worse. So it's really wasteful.
I wanted to ask about the particulars of the star. I mean, I feel like we kind of got into what novas are, and then this star a bit fast. You mentioned Tycho Brahe, who one of my favorite stories. I think he was on the Isle of Rhodes, right, making the first comprehensive star charts, which is the star maps, which is how he noticed the new star in the first place. And I'm curious how the situation was different. You mentioned 1946 when this star was first, I guess this nova was first seen. So how did scientists detect it then? And how far away is it, from us in terms of like light years? I mean, it's in Corona Borealis. I should have mentioned that's the Northern Crown. If you're looking for
it is the Northern Crown,
the name of the constellation for everyone out there. But what are like the particulars? Is it like a Sun class star, or it's a white dwarf, but is its partner a Sun class star or anything like that?
No. So the partner of the non-white dwarf star in the binary system is what we call a red giant.
Red giant. Yes, you said that.
It's an M-type red giant, so it's a red star. But normally you can't see it, not with the naked eye. You can see it with a telescope, but not with the naked eye. It has a binary period of a little less than a year.
Okay.
I think it's 230 days or something like that. And it is at a distance of just shy of a kiloparsecs, about 800 parsecs, which for stars in the Milky Way, it's pretty close. And as I was saying before, this one is special, or it's unique in the sense that novae themselves are rare. So there are not that many in the Milky Way. Recurrent novae are even rarer. So this happens to be the closest recurrent nova, or one of the closest, right? And so this is why it's an opportunity for people to see without any instruments. It's going to be bright enough to see with the naked eye. So that's the sort of the typology of the system. It's a 230-day period. It's a M-type red giant with white dwarf orbiting around it.
And you said it's about a 100 parsecs from.
It's about 800 parsecs away.
800. Okay, so that's like. So for our Star Wars fans, that's like 80 Kessel runs. I think is what that is.
God.
So, and then how was it first spotted? Was it just an astronomer looking up at that spot, or they noticed it?
I do not know who found it first, but you made a very good point before, because in order to recognize that a star is a nova or a supernova, what you really need is you need to know what's there normally, right? How do you know the star is new? Well, because it wasn't there before, because I know what the stars were like before, right? So even Tycho Brahe was the first one to identify this kind of new star, and he wrote a book that made him famous. But this is something that has happened before and will happen again. Astronomers got really good at identifying novae when we started having really good maps of the sky, because that's what you need. It's like you see something, you say, oh, this wasn't here before. By the way, this is also what you need in order to find things like planets. So when Herschel discovered Neptune, because he was compiling a map of stars, and he could say, well, this wasn't here last month. So something's going on, right? For TCrB in particular, the 1946 eruption was pretty well documented. But I don't think it was the first one. I think it was whatever happened in the 19th century. I think that was also noted. I don't know off the top of my head, but
I like that you called it TCrB, like it has its own nickname now.
Well, the T comes from astronomical nomenclature doesn't make a whole lot of sense sometimes, but this nomenclature with a single letter in front of the name of the constellation, this comes from variable stars. So, and most novae are variable stars recognized in this way. There is another famous recurrent nova in the constellation of Ophiuchus called Ares Ophiuchi. And that one has an even shorter recurrence time. That one's, I think, 18 years.
Oh, wow.
Yeah.
So you kind of covered this at the beginning, but by your definition of nova, our sun can never go nova because it doesn't have a companion.
Doesn't have a friend. And it
So
can't.
sad.
Yeah. So sad. And it can't go supernova either. So
right. So
we're safe.
What it's most likely to do is just slowly dim and burn out over time.
Yes, it will become a white dwarf in the future, but that's not for another 5 billion years. So I wouldn't worry about it.
I'll still be sitting at that cruise ship buffet. What Tara?
Just again, to all the parents of young kids, do not describe the death of the sun to your toddlers.
Oh, did somebody have an experience with that?
Because they will look around and start wondering what's going to happen to all their toys and all their stuff, and where are we going to be when you're telling them that the sun's going to swell up and envelop the earth for a little bit. And
we're all going to be comfortably dead.
Yeah, that happened to me, and I leaned down and whispered in my son's ear, "Your toys will all melt, and your parents will be charred husks. But you'll be just fine because you can hide under the bed." Okay, we got to go to another ad. We'll be right back. Stand by. Hi, Tarek.
Oh, I'm on the wrong window. I'm on Rod's window. Oh my gosh. So, well, Carlos, there's been a lot of talk in the media, to try to get people really excited about this nova that it's coming up. And you mentioned, September-ish is the time frame. And one of the big, I want to say, like criticisms maybe that that I get from time to time at space.com, and Rod will agree, I think, supermoon, right?
You mean to say clickbait?
That we overhype these types of events. And in the media, Carlos, the nova it's being called the Blaze Star now, which is really fun to say, really fun and catchy. And I'm wondering, because I can see your excitement as a scientist, as an astronomer, about being able to witness this event, to see it, to study it as well. Yep. But is the media overhyping this because you mentioned that we know that there's a bunch of these ones, or is it just another a reason to get excited about the fact that we live in a universe where we're not the center of it all, and here's an example of stuff happening beyond literally our sphere of influence to show us that we live in just a changing, dynamic cosmos?
To me, that's exactly what it is, Tarek. The fact that our universe is dynamic and that the night sky changes, and it's something. If you want to think about it that way, I just find it so fantastically unlikely, right? Because the tools that we have to explore the universe are our eyes. And our eyes evolved to keep us alive. So our eyes are good at, seeing things that are good to eat and things that might eat us. So our eyes were not developed to do astronomy. The astronomy is of no interest to stay alive, day to day. And yet, every once in a while, something like this happens. You can see a new star in the night sky. And I'll be the first to admit that, if you start calling this the Blaze Star or people who actually go there may be a little disappointed because it really is.
But Carlos, NASA called it a once-in-a-lifetime event. Because right?
It is a once-in-a-lifetime event. It is a once-in-a-lifetime event. It's probably the brightest nova you're going to see this generation. Mm-hmm. And again, novae explode all the time. I am working now on a sample of novae in a nearby galaxy called M31, the Andromeda Galaxy, right? And we've recorded, hundreds of novae in M31. So if you have a big telescope and you take pictures of novae night to night to night, or the galaxy night to night to night, then you can see these things light up and fade away, right? And to me, as an astronomer, this is just the beginning, right? Because then you start asking the question, so we understand the basic mechanism, but how does this work in detail? What types of stars particularly go through this phase, and why do they do it? And these are all fascinating questions. Well, at least to me,
And I guess if we do the math, I mean, if you miss this one, for the Blaze Star, I like that. I'm going to call it that. If you miss it, you're going to have to wait till what? 21 24.
You know, if you want to,
21.
if you want a naked eye one, I don't know. There may be another one that's naked eye, but this one's going to be pretty bright. I mean, magnitude 2, just for people who don't think about this very often, but magnitude 2, it's one of the, say, 200 brightest stars in the sky. Okay, so it's not going to be like as bright as the moon or anything like that, but it's pretty bright. And another thing that I find fascinating, because, and admittedly, this is actually my field of expertise, right? We understand pretty well what a star like the sun will do in its lifetime. You know, with this is a field of study called stellar evolution. We understand how it powers itself, how it supports itself and its gravity, and we know what's going to happen once it exhausts its hydrogen, which again is something that will happen 5 billion years into the future. Well, we have very, very little, we know much less well, is what happens when you have these binary interactions. Okay, when stars start exchanging mass. And this is something that is a very active field of study. And it's full of uncertainties. It's just it's a big adventure, big unknown. We really don't know the details of what happens to these binary systems.
So I think I just had one more, because you mentioned that it's going to be, you know, around the brightness of like the top, what did you say, 200 stars, or is that the brightest stars?
Yeah. So if you're familiar with the shape of Corona Borealis, it's going to be as bright as the stars in that constellation.
But to make it clear for people, because they're going to hear Blaze Star, new star in the sky, it's going to be super bright. It's not going to be, you're not going to see it during the daytime at all. I mean, that's very clear.
Exactly. You're not going to see it during the daytime. And if you go out at night and look up, you're not going to be able to identify it unless you know where to find it. Mm-hmm. Okay. It's not that easy. It's not that hard to find. So Corona Borealis is right next to a large constellation called Badenes. And the brightest star in Badenes is Arcturus, which is one of the brightest stars in the sky. And that one's very easy to find. That's the star that you find if you kind of follow the handle of the Big Dipper. Follow the curve, it takes you to this very bright star. Corona Borealis is just on the other side. So it's the Big Dipper, Arcturus, and then Corona Borealis. So are you going to pass Spica? Because you take the arc to Arcturus and straight on to Spica. So do you? No, before Spica.
Okay, all right. Now I know where to look.
Yeah, you know where to look. So the thing to do, if you want to really make the most out of this experience, is to go out now, okay? And make sure that you can find Corona Borealis and get a mental picture of what that looks like without the nova, okay? And then when the nova goes up, you'll be able to go out and, you know, either by memory or because you have a picture of Corona Borealis in front of you, you'll see, oh, well, that's the new star. Okay. It's just going to look like a star.
I feel like I'm sitting in a conference of planetarium directors with this. How did it go? You spiral to Spica and something to something.
No, you take the arc of the handle of the Big Dipper to Arcturus, the arc, and then straight on to Spica. And then
spiral to Spica is what they said.
Oh, I used to always say straight on. That's how
you're at the wrong planetarium. So are there any famous novas in history that were conjoined with any historical events we might recognize?
Oh, well, yes. So probably the most famous nova is Tycho star. Today we call it Tycho supernova. And it's, funnily enough, it's the object on which I did my PhD thesis. So
congratulations.
I really know it through and through. But a few years after Tycho supernova, Kepler, who was actually a collaborator of Tycho. They worked together. So another one, which we call Kepler supernova. So Tycho supernova was in Cassiopeia, and Kepler supernova was in Ophiuchus. So for the stargazers out there. And if you go out and look at the night sky, you won't see anything. What these things are now are supernova remnants, right? And they're bright in the X-ray, so you need an X-ray telescope to see them. the once we recognized that this was the phenomenon we call a supernova, people looked back into the historical records and they saw several instances of people noticing this. There was one, for instance, in year 1054, which is what we call the Crab Nebula. Now, that was the supernova that gave birth to the Crab Nebula. There was one in 1006. In the height of the Middle Ages, that was so bright you could see it during the day.
Wow.
Yes. And Chinese astronomers measured others. So there's not many, but a handful of known events that have been recorded in history. And of course, the people at the time didn't know what they were.
I was going to ask, did it freak them out? You know?
Well, funnily enough, if you like history, so Tycho and Kepler came, in the height of the Renaissance, and this was when people's conception of the night sky and the universe was starting to change. And the discovery of Tycho's supernova was important because if you remember your history, the ancients used to think the night sky was perfect and immutable, and that came from a conception of the universe from Aristotle. It was supposed to be everything that's sort of changing and corruptible is down here on Earth, and up there in the heavens, they're just perfect, right? Mm-hmm. And then Tycho finds this star that wasn't there before, and then it fades away and it disappears. So that's not perfect and immutable. Something different's going on here. So that discovery kind of entered the debate on what it means. And now, of course, we recognize that, the night sky is dynamic, as you guys were saying, and it changes all the time. But changes that are bright enough to see with the naked eye are rare. And this is why TCrB is exciting.
Well, you'll be glad to know that our friend Tarek here is incorruptible. I've tried.
That's right.
So I guess he puts us in that class. We'll be right back after this last ad break. So stay with us. So Carlos, do you have any other research you're working on now or in the near future? Or is this kind of really what's occupying the majority of your time?
Oh, no.
It's happening now.
I'm always doing many different things. So one of the things I'm doing, as I was saying before, I'm looking at novae, but in different galaxies. So that's a fun project. I'm also looking at supernovae with the Hubble Space Telescope. We have a project to take pictures of galaxies that have hosted supernovae and try to understand what sort of stars give rise to this phenomenon. And this is related to what I was saying before, because the particular kind of supernovae that interests me, the thermonuclear supernovae, also come from binary stars, also involve a white dwarf. This time the white dwarf explodes. But we don't know exactly what type of binary star leads to this. It's one of the big open questions right now in astronomy. So we're using the Hubble Space Telescope, which have a Lego model right there in the back.
I noticed earlier. I was going to ask about it at the end. Yeah,
and I can't take any credit for it because it was built by my son. But we're using Hubble for that.
Well, I'm curious in your studies. I mean, what's the fastest nova that recurs, and is there one that you've come across in the history? So it's two questions. So one that you come across in your historical records that you really either hope to be able to see again, or that you wish you would have seen the first time.
Well, the record holder for the shortest recurrence time is actually a nova that is in this galaxy that I'm studying now, M31, the Andromeda Galaxy. Mm-hmm. And it has a recurrence time of about 1 year. Goes off every year. Yeah. And to us, that is interesting because we think that what dictates the recurrence time of the nova is the mass of the white dwarf. So more massive white dwarfs lead to shorter recurrence times. That's
the star that blows up is
the star that on the surface of which the thermonuclear runaway happens.
Okay.
The star itself doesn't blow up.
That's right.
Only in the supernova, not in the nova. So that one has a very short recurrence time, and it was discovered not that long ago. It's very interesting. It has you can see concentric shells of expanding material around it when you look at it with a deep image of M31. So that was very cool. More than finding a particular one, I would really like to know what type of stars lead to the supernovae. This has been something I've been working on now for decades, and it's one of those problems that you want to look at from many different points of view because it's a tough one. So far we have not cracked that one open.
Wow.
But, we will one day.
So just for my edification, when you talk about looking at that problem, how do you look at that problem in simpleton terms for people like me?
Okay. So here's one key difference between novae and supernovae. So novae are, relatively speaking, more common, even though they're rare compared to other stars. They're much more common than supernovae. There are dozens of novae in a big galaxy every year. Typically, for a galaxy the size of the Milky Way, there's a supernova every 100 years, roughly. Okay, so these are very rare events. Now, because of that, the vast majority of the supernova we know explode in galaxies that are very far away. Just because if you just stare at your immediate vicinity, you will have to wait for a very long time. So what that means in practical terms is that we never get to see the star that explodes because it's just too distant. So not unlike these TV shows like CSI type shows where, there's a crime scene and you didn't see what happened, but you are trying to put together the evidence and see, well, I think this is what may have happened here because of this and that. It's about putting clues together. One way to do this is to try to look at the statistics of the regions of the galaxies where we know the supernova explode and see if we can glean some of the properties of the stars from there. But these are all indirect because the stars themselves are just too far away, right? So, of course, the dream of any astronomer who works in this is to have the next galactic supernova, right? Mm-hmm. And we're kind of overdue because the last one that was observed and recorded was the one that I told you about by Kepler, and that was 1604.
Oh wow!
So we're owed 4 supernovae, and we're waiting. It could happen tomorrow.
Well, then I'm definitely not betting you for your chair for a supernova, buddy.
well, aren't we watching Betelgeuse for that, Carlos? Like,
yes.
Isn't that the Betelgeuse in Orion, where we're waiting for it to blow up and it's doing all sorts of weird stuff?
Yes. So there are two ways to make a supernova. One is to completely explode a white dwarf in a binary system, and this is what we call a thermonuclear supernova or a type 1a supernova. And the other is what we call a core collapse supernova, and these are very massive stars. So when I said before that the sun cannot explode as a supernova is because it doesn't have a companion, so it cannot be a type 1a supernova because you need a binary for that, and it's not massive enough to be a core collapse supernova. Core collapse supernova progenitors are around 8 times the mass of the sun or more massive. Mm-hmm. And these massive stars, they live like rock stars. They shine, they're very bright, they have very brief lives, and they go out in a spectacular event, right? And Betelgeuse is one of the closest ones. And yes, when that one goes off, it's going to be spectacular because it's also relatively close. And of course, it's one of the brightest stars in the sky, right? You can see the constellation of Orion. It's the red star in the constellation of Orion. And when that one goes off, it's going to be spectacular. Going to be very, very bright.
That'll be kind of like the end of Mick Jagger, I guess. Sorry, go ahead.
I had one more about T Corona Borealis. By the way, I know we talked about parsecs earlier. I did look it up. It's 3,000 light years away. So if people are light year dependent, that's the main distance there. But is there a limit to how many times a star like T Corona Borealis can go nova? So we've got at least 2 that are coming up now. I mean, is there a time where its companion just runs out of material?
So that's one of the things that we don't know. If if you recall, I was telling you guys how stellar evolution is something we understand roughly when it comes to isolated stars, but whenever you get to binary stars, there are all these questions that we don't really know the answer to. One of these questions that we don't know the answer to is it possible for nova to keep going through these explosions and have them more and more often and more often until the white dwarf itself becomes unstable, and you end up by having one big supernova explosion. And some theorists think that that is possible. Some others think that maybe not. Because when the material that's on top of the white dwarf explodes or blows up in the nova explosion, if you look at it with a telescope, you see traces of the material that was accreted from the companion, so the mass that was put together from the companion, and also a little bit of the substrate from the white dwarf.
Oh.
So maybe what nova explosions do is they actually erode the white dwarf, make it less massive, and less massive white dwarfs tend to be more stable, not more unstable. There's a magic mass, about 1.4 times the mass of the sun, that white dwarfs cannot reach. They become unstable when they get close to the mass. And one of the models for supernova explosions is that you need to get the white dwarf to this close to this value, and then it will become unstable. And
is that the Chandrasekhar limit? Is that
is the
that's what? Oh, I know things. I know things.
Nailed it.
You nailed it. That's the Chandrasekhar limit. Yes.
Oh, also, so it sounds like they're like jawbreakers and they erode out. But then I think that raises the stakes, Carlos, because wait, like what if this one is the one, right? And if I decide to skip it and wait to the year 2104 for the next one, which I'm sure I'll make it that far, but but then I will have missed the big show. So I think that raises the bar of why you should go out and look for it.
Yeah, and this is why this other nova that I was telling you about, Ares Ophiuchi, has been much discussed in this context because its recurrence time it's even shorter, right? So people say, oh, maybe Ares Ophiuchi will go off as a Type 1a supernova explosion, as a thermonuclear supernova one of these days. I don't think so. I have reasons to think that's not the case. When we look at Type 1a supernovae, they usually have very clean environments for whatever reason. There doesn't seem to be a lot of hydrogen laying around. In fact, that is what Type 1a means. It's a supernova explosion that has no hydrogen. And a very strong line from silicon. But the thing with Ares Ophiuchi and other novae is that there's a ton of hydrogen lying around because this mass transfer process is not 100% efficient. It's very messy. Okay, and they're beautiful objects. You have bipolar outflows and disks and all sorts of things, right? So it seems that there may be different classes of accreting white dwarf, but we're not sure.
Well, this has been sensational. And Carlos, I want to thank you for joining us and thank our audience for joining us for episode 122 of This Week in Space. You can learn more about science and space and astronomy at space.com, of course, because
also science.
The website's in the name. Some science. Actually, for science, I go to Live Science, which is your companion website.
You're burnt.
And the National Space Society at nss.org. Carlos, where can we track your ever-brightening career online?
Thank you so much. Thanks, Rob. Thanks, Terry. Thanks for having me.
Where can we find you online for this kind of news?
I do have a website. Of course, you can find me through the University of Pittsburgh, which is what I work where I work. But I have, if you Google my name, you'll find my website.
Okay, and Tarek, where can we track your amazing life achievements?
Well, you can find me at space.com as always, or on the Twitter or the X, I guess we're calling it now, at Tarek J. Malik. And if you like video games, you can find me on YouTube at Spacetron Plays, where you can get a Cybertruck for free from Fortnite, which I'm pretty excited about right now. So,
oh, wow.
Have you seen one on the freeway?
I have seen Cybertrucks in my town, and it has a big bumper sticker on it, and it says you can rent this Cybertruck, and I do not want to rent the Cybertruck. So
I've probably owned 30 different cars at this point. Sorry for the aside here, but I was driving down to San Diego for an Apollo 11 anniversary event last weekend, and there was a Cybertruck stuck with me on the 5 freeway for 5 hours to drive 120 miles. And I gotta say, I love cars. It was one of the ugliest things I've ever seen on 4 wheels. Really sad.
You see it on Mars and on the moon.
Yeah, maybe so. Please don't forget, you can drop us a line anytime at twit.tv. That's TWIS at twit.tv. We always welcome your comments, suggestions, and ideas, of course. And new episodes of this podcast published every Friday, as you certainly know, on your favorite podcatcher. So please be sure to subscribe, tell your friends, give us reviews, write Carlos a love letter thanking him for his appearance, whatever you want to do. We count on you because you're the only reason why we're here, listeners. Don't forget, you can get all the great programming with video streams and more on the Twit Network ad-free with Club Twit for only $7 a month. And what a bargain that is. Finally, you can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook, and twit.tv on Instagram. Carlos, thank you very much for joining us.
Thank you, guys. Thanks for having me.
Tarek, thank you for being cute and clever. And we'll see everybody next week.